Hi, welcome back to Mthpt-153 Elementary Statistics, and we are finishing up Chapter 2. We are going to finish up doing scatterplots and correlation and regression. So a scatterplot is a graph, and you should have learned about it in the previous section, where you take a bunch of dots that have a relationship, an x and a y axis, and you put them on a graph and see if you can notice a relationship between them. So we're going to do that, and we're going to focus on a linear relationship. So hopefully when we see the pattern, we can see some form of line forming. And then we're going to look at the correlation coefficient, the regression line, and the p-value to see how well the two variables are correlating. So correlation, and that's the idea that two variables have some sort of relationship or association. Now there is a saying that correlation does not mean causation, and we definitely want to work on that in this class, because we can show any two things being correlated, but that doesn't mean there's a true cause of the explanatory variable for the response variable. We talked about a scatterplot already. It's a plot that has paired data, an x and a y axis, and we'll see those on a graph. So here's an example of your waist circumference and your arm circumference, and is there a relationship? And as you look at this, you can see that there might be a relationship. It tends to, as your waist circumference increases, your arm circumference tends to increase. It's not as good of a straight line as we would like, but it does seem to be correlated. This example doesn't have any correlation. We have dots everywhere, and so because our dots are all over the place in what we call a shotgun effect, there is definitely not going to be a correlation. With our linear correlation coefficient, the value r, which we will find using our stat disk, it also can be used with any graphing calculator if you have that type of excess, but we're going to focus on using stat disk. Your R value needs to be between -1 and 1. If you have a positive correlation, then you will have a positive number between 0 and 1. If you have a negative correlation, then you will have a negative R value between -1 and 0. The closer it is to 0, that's more of the shotgun effect that we saw earlier. The closer it is to -1, it will look linear in a negative slope. The closer it is to +1, it will be more linear in a positive slope. So here's some data that I put into StatDisk, and you can see from the results here, I have an R value. I'm going to grab my pen real quick. I have an R value of 0.59, so that tells me I do have a positive slope because my R value is positive. Now, it's not really close to 1, but it's not really close to 0. It's kind of in the middle. So it's not great, but it's okay. Now the p-value is 0.29369, and we'll look more at that later. We also have what's called an R-squared value, and I'm going to go ahead and talk about that now. So all they did was they took our R value and they squared it, and what this helps us know is how much of the explanatory variable explains the response variable. In this case, I used the shoe print length as my x and the height as my y, and I plugged it in. I can see here's my equation. Y equals, my b naught is the y-intercept, so it's approximately 125.4, plus my slope, we'll go 7.3, it's a 7, with my x. So here's my equation. It's definitely linear. Slope, y-intercept. It's positive, which makes sense because my r is positive. Now back to the r squared, what this is saying is if I turn this into a percentage and move it over 2 decimal places, that approximately 35% the response variable, or the height in this case, is explained by our shoe print length. So our shoe size has about 35% to do with our height. So there's obviously 65% other variables that have to do with our height. Now the p-value, which was in the previous screen, but I didn't talk about it, is the idea that we want to know what's the probability that this will occur by chance. And if it's very slim to occur by chance, then it has to have some sort of relationship. The problem we just did, we had a p-value of 0.294, and I can see that if I look back on that one. So here was my p-value, 0.29369, so they've rounded it to 294. So 294 is very high. We try to shoot for a p-value that is less than 0.05 for most items. Sometimes as we go on in this class, we might use a 0.10 p-value, and on things that are critical to our health, we definitely want to go as low as a 0.01 or a 1% p-value. And so this is what this slide is talking about. We're going to go for 0.05. The numbers that we just saw were definitely higher than that. 0.294 is much higher than 0.05. So it's not going to occur similarly just by chance, so we don't think it's much of a correlation. So here's another example. I have the carbs in our food compared to our calories in our food. And I did use the carbs as our x variable, and I used the calories as our y, or our response variable. So we had 8 numbers plugged in, so there are 8 here. So our R value was 0.993784. That is a much higher R value. In fact, it's almost all the way to 1. So that means there's definitely a good correlation here. Our p-value, notice it's pretty much 0. So that's definitely good. It's definitely going to not just occur by chance. Here's our equation. If I were to write it out, it would be y equals negative 1.43 plus 4.7x. I have a positive slope. I have a positive r. Those should match up every time. If I keep going down, I see my r squared down here at the bottom. Move it over. Looks like about 98.8% of our calories are determined by our carbs. And that's a lot what nutritionists tell us when we look into that. The regression line I've actually written out in both of the previous slides where we put in data. So we are using this form, and in some of your technology, they might give you the options of using y equals a plus bx, or what we're more familiar with when we're dealing with lines is y equals mx plus b. And so they're all just different forms of a line. Here's a picture of a scatter plot. So these are all the individual points that were put on there. Here's our carbs data versus our calories data. Now remember, our R value was fairly high. If we look back, our R value was 0.9937. So you can see that that is a great, look how close that is to the line. So that's why our R value is so high. It also has where we can see the equation. We can do this on Excel. It also can be done on your stat disk. Now I have gone ahead and uploaded a stat disk tutorial so that you can use it to perform your regression equation and all your regression data. Make sure you do that. If you have trouble, let me know and I will send you some information. Have a good day, and this completes Chapter 2.